Okay? So, kanila na natin is dili build up in terms sa iyang account. So, karon mangutana ka, sir, pwede ba nga duha ka file ang itugang? Yes, pwede mo. Pwede po kami ng second part yung itugang namin. Pwede na siya. No? Saan ka ng lugar? Ano?
Okay.
Pwede na ba inanapon mo? Lugar? Dahil, nakasiipon na ba sa second
Okay,
floor?
so last week we had our quiz number 3 no, and then the previous week po we had quiz number 2. Wala pa na ako i-post ang ato ang solution kay I'll be giving pa special quizzes for those students who have not taken the exam the quizzes pa so from other sections. Wala mang hindi mo also post for everyone. But all of those questions are nakuha ra ko to siya sa mga reference books na akong gipanghatag sa inyo on our orientation. So, if you wanted to know the answers, pwede na to rin yung pangablihan. No? Nara to sa Beer and Johnston, sa Pytel, and Hibeler ng mga libro. So, pwede na. No? Nakaka-download naman mo anak ng mga libro. So, kindly check na lang and share with everyone to those who have downloaded those PDFs. Okay, now, on the previous chapter, we have discussed about the equilibrium of a rigid body in two dimensions. And we saw in that earlier part of this chapter that there are 6 scalar equations that are required to express the conditions for the equilibrium of a rigid body in the general three-dimensional case. No? Such that summation of forces along x, y, and z must be equal to 0. In 2D, we only considered summation of forces along x and y. And then the third equation is summation of moment along the perpendicular axis of the two components containing these forces. Diba? So isa na kabuk. There are 3 conditions for equilibrium for 2 dimensions. However, in 3D, tulo na po. No? We are going to express our moment in terms of its x, y, and z components as well. Okay? So, summation of forces must be equal to 0, meaning 0 displacement along x, y, and z. And no rotation about x, y, and z also. Okay? Now, these equations can be solved for no more than 6 unknowns. Okay? Kay, kuno mo naman pud kabuk ang ato ang conditions for equilibrium. Therefore, it is limited to 6 unknowns lang pod ang ato ang ma-identify, making our problem determinate, no? Which generally represents the reactions at supports and connections. So in 2D, we have, I have shown you the table of different groups of reactions, no? Kung pila ka buki ang unknowns and pila ka buki ang reaction depending on what supports or connection that has being used in the structural system or in the structural member. Now, in most problems in most problems that we are going to solve, the scalar equations will be more conveniently obtained if we first express in the vector form the conditions of the equilibrium of the rigid body that we are going to consider. No? Kung natay vector, natay tulok 6 equations with 6 unknowns, if you're going to recall your topics in matrix, pwede po na ito na siya ma-solve. Diba? Kung 6 equations with 6 unknowns. But, with the conditions of equilibrium, kaning unong kabuok na ay uban ani ng mga problems na pwede nito ma-combine. No? Making it, pag ma-simplify na to ang atong equations, mahimo na lang siya, round down na to siya into either 2 equations with 2 unknowns or 3 equations with 3 unknowns. But if dili gani na walay makombine among the 6 na equations, then we have to manually solve the solution of the equations. So kung unom ka buok ang anon, so unom pud ka buok ang ato ang kuhaon nga value. So we write the conditions of equilibrium as the summation of forces is equal to 0 and summation of moment in terms of its vector form, the summation of all position vector times its force vector. So kung daghan nga forces ang atong ma-encounter, kuhaan nato og moment about a reference point, each force that has different position vector cross multiply or cross product of the two vectors, isum up na to na siya in terms of its x component, y component, and z component, and then equate it to 0. Okay? Now, we can express the forces F and position vectors R in terms of the scalar components and its unit vectors, such that wala to ang Fx, Fy, and Fz, and then Rx, Ry, and Rz. So that kung atong i-multiply, then ang ato ang moment nga makuha is in terms of its scalar components or in unit vector form. No? Ato na ijk. Next, we compute all the vector products either by direct calculation or by means of determinants. Okay? So determinants is when you use your matrix. Diba? I-arrange na to ang atong equations with its coefficients, and then pangitaon na to kung upat ka rows, kuha na to get its determinant. No? Diba? Na may na nga solution sa matrix, and that is still okay. No? Kung ganahan mo nga magamit mong determinants, pwede. Okay? Now, by equating to 0, the coefficients of the unit vectors in each of the two relations, we obtain the desired scalar equations of each of the conditions of equilibrium. Okay? Now, we have here another set of reactions at different types of supports and connections for 3D. Okay? There is a slight difference when you analyze a 2 dimensions and a 3 dimensions. Okay? Kaya nga naman, ang roller sa 2D, isa ra kabuok ang atoang reaction. But pag abot sa 3D, mahimo na siyang duha. No? However, nagya po yung mga types of supports and connections in 3D that has only one unknown, such that if the support of the body is a ball, no? A ball meaning it is allowed to move freely along x and the z axis, but because gipatong man siya din na, it is restricted to move along the vertical direction. Therefore, there is one reaction with one unknown for these type of supports. No? The normal force that is always perpendicular to the plane containing this plane nga allowed ang movement sa tuang body. Okay? Vertical na po. And then for frictionless surface, iguro siya gipatong, it can be moved, rotated along x, y, and z. Ang rotation ani pwede po siya along x, y, and z. So there will be no reaction force from this plate to the body. No? One known unforced sa gihapon that is perpendicular to the surface ani niya. Okay? For cables, always, no, say cables, all forces will always be along the cable. So known ang ato ang line of action, only one unknown, the magnitude of that force. Okay? Same with this ball and frictionless surface, known ang ato ang line of action that is always perpendicular. Now, for roller on rough surface or wheels on rail, no, this roller can freely move along the x-axis. But because it is pinned, no, from this body to this support nga roller, it is not allowed to move along the z-axis. Muligid ang ato ang ligid, di ba? Diha ramon po siya padulong. It is being restricted by this pin here. No? The same with your y component. Sa ato ang reaction. Tungod kay gipatong na siya din ha, it is restricted to move along the y-axis. So, also, tungod kay wheel man na siya, pwede ra sad siya matuyok-tuyok, di ba, at any axis. So the reaction force only, the axis of restriction for this type of supports is along the z and the y axis only. Okay? Same with the wheels on the rail. No? Yung wheels on the rail, it has a guided displacement along the x-axis. But because it is being connected, no? Gi-restrict na siya, na-bolt din ha, dili na siya pwede ma-move towards the z-axis. Same with the y-axis. So there will be two force components for these types of supports. Next is for rough surfaces. Since rough surfaces at any angle or at any at any direction along the zx plane, no, there is a friction force that is always parallel to the movement of the body. So, because of that friction force, tulo kabuk ang atoang components of that, no? Ang y, it is restricted kay gipatong man siya din ha, di ba? Ang z, no, ang z ug ang x, it can be na ay resisting force, no, due to friction along these two axes. So therefore, tulo kabuk ang atoang reaction force for these types of supports. Next, for ball and socket, the same, mura og kanang joystick, di ba? Imagine ang joystick, pwede naman nato na siya matuyok-tuyok anywhere, but it is not allowed to move along x, y, and z axis. No? Next, for the universal joints, there are three. Gihapon ang atoang components. Kaya naman, it is restricted because it is naa siya connection at this, no? Dili na siya pwede ma-move. Kay kung ato siya i-move, naaman ni, no? Na yoke diri na mag-restrict to movement at any direction along x, y, and z axis. But if we're going to rotate, no? Ang kaning ato ang body, it can be moved, it is restricted to rotate along this axis. Kaya nga naman, kani rigid na siya. Rigid pud di siya, di ba? So, it is restricted to rotate at this axis, sa x-axis only. And also, kung kani, no, although rigid di silang duha, the direction of the yokes, ang iyahang only restriction is the rotation along the x-axis. But it can be freely rotated along the y and the z-axis. So, pila ka buok ang atong anong? Upat ka buok. The forces and one restriction sa along sa to ang x-axis. Okay? And then, next are for fixed supports. For fixed supports, kana mga gitugsok, no? Dili na to na siya ma-move given that this plate, kung asa siya gilubong, is also rigid and the body is also rigid. So, at any direction, it cannot be moved along x, y, and z, and at the same time, it cannot be rotated along x, y, or the z axis. So there are how many? 6 total unknowns. The magnitude of these three forces and the magnitudes of the components of the reaction moment or reaction couple generated by this fixed support nato. Okay? So where there is a restriction in movement, the body of contact, no, ang body, ang kaniyang surface na nag-contact sa ato ang body of consideration will will tawag anang mo generate siya or mo react pud siya to the body with an opposite but equal opposite but equal direction of the forces that is being applied from the body to the surface. So inana gyapon ang surface pud mo hatag pud siya reaction niya ana. Okay? So next, there are also special types, no, of supports, especially in 3D. So these are some of the many. Kay as of today, daghan naman kayo og mga types of kanang mga connections, no. So the common ones nga atong mga makita, pod ni siya ang iyang mga number of unknowns. Okay? Now, we have here a hinge and bearing support, and hinge and a bearing, no, supporting radial load only. Okay? So, ang kani, ang atoang body of consideration, this one, it can be rotated, di ba? It can be freely rotated along this axis, along the x-axis. But it cannot rotate along the z-axis and the y-axis. So there will be a reaction couple along the y and the z-axis. But since it can be freely rotated along the x, now also the displacement of this body nato from this rod kani ato ang ring, no, or inani nga mga connection, it can freely move along the x-axis given that if this rod is frictionless and also this ring can be, or this hinge is also frictionless. So it can freely move along the x-axis, but it cannot move along the vertical and the z-axis. Okay? Unless butangan na siya og bolt din ha. No, kung butangan na siya og bolt din ha or stopper, then it cannot freely move along the x-axis. So nagyapon na siya reaction force along this direction. Okay? So you have to analyze ang 3D kung asa na ay restriction of its movement, displacement along x, y, and z, and rotation along x, y, and z. So that, pag abot ninyo sa inyong free body diagram, dili ninyo na siya kalimtan kay remember in the conditions of equilibrium you have in your free body diagram also you have to identify all known and unknown forces. Kay kung nalang kay isa ka book nga dili nimo ma-include din ha, udi pag sum up nimo sa imong free body diagram wala nimo na include og butang ang moment reaction at this point, then so may tabo, dili mo siya i-include sa imong equilibrium equations, then you have already destroyed or wala na siya na nimo na satisfy ang equilibrium equation niya. Okay? So you have to include all known and unknown forces. So you have to be very familiar with different types of supports and connections. And to do that, you have to practice more. You have to solve more problems, no? Dili lang ta sa ihatag nga examples kay na ay daghan ng mga problems from the reference books that I have given you. Okay? And I am proud to say that in my college years, I have tried no mga 70% or 80% of those problems from that book nga akong gihatag sa inyo, especially katong kang Beer and Johnston, na solve na namo during our college kay aron dili na mi maglison on the next nga mga subjects po namo. Okay, kay ang uban pod ana nga mga problems pabalik-balik na pag abot dito sa theory of structures mobalik na sad na siya. No? And in statics, it is very important na makabalo pagkuha og reactions. Kay kung dili ka kakuha og reactions, na di gid ka makasolve gyud og kuan. Di ka makasolve, makaproceed sa inyong strength o theory. Kay kung pagkuha lang nimo sa reaction, ang inyong solution, you're already halfway of your solution sa mga higher ninyo nga mga problems. So you have to practice this, no? Dili lang sa 2D, appeal pud sa 3D. Okay, so I was also encouraged no nga apilog gyud ang 3D pag-discuss sa statics kay kasab-an ta sa inyong mga maestro pag-abot sa third year kay di din mo makakuha ng space ta so lisod na din ninyo ma-imagine may nang second year pa lang ma-practice na mo pag kuan no pag draw or pag analyze og 3D ng mga rigid bodies. Next is for pin and brackets. So pin and brackets kana no gilansangan na siya din ha. It can freely move along this axis. Diba? So that depends di pod ha sa orientation kung asa dapit na ay restrictions. Okay. Not all the time along X ang na ay free body no. What if gituyok na siya? Diba? Along Z ang allowed movement. So you have to to analyze the orientation of the connection. Kay kung asa ang orientation sa connection, there is the restriction of movement. Hence, there is a reaction force or moment on that axis ato ang connection. So, in the pin and bracket, kana gilansangan din no na ana siya iyang restriction. So, along X, Y, and Z, it cannot move. But along the Z-axis diri, it can freely rotate. But along the Z-axis, dili pwede. Along Y, dili pud pwede. di ba? Pero kung tuyukon na to na si pin and bracket, ahaman siya freely to rotate along the z-axis, no? Kung atong tuwangon na siya, asa man na siya pwede ma-free mo rotate along the y-axis. Kung ato na siya ipilit sa wall. So you have to be careful, no? Ato na siyang i-imagine. So that depends on the orientation. Kung asa dapit ang naay restriction for movement and restriction for rotation. But we know, since this is pin connection, bolted na siya din ha. So along x, y, and z, wala gid na siya movement. Asa karon ang naay allowed nga mo rotate siya along the x, y, and z. So kana dinha pa lang dapat ma-identify na nato ang reaction moment, no, sa ato ang connections. For hinge and bearing support, supporting axial thrust and radial load. So when you say axial, it is always perpendicular to the point. No? So sige lang, makuha na siya ninyo puhon pag abot sa inyong strength of materials. Kaya importante na siya kay kung pangutanan din mo what is the actual stress and the shearing stress. O balo na mo nga si axial always perpendicular to the area of consideration. Ang kag-shearing, always parallel po the area of consideration para makuha na to ang stress. So, for axial thrust and radial load, it means that along, no, kani siya, wala man na siya iyahang bolt din ha or washer to stop the movement along the x-axis. This one, no, it is not allowed to move along this axis. And sa inyong strength, puhon, no, kung makabalo ka, pilay force nga mo apply on the axial, no, along the x-axis of this rod, pag abot din dito sa strength, ang pangutana dayon, how thick is the bolt? La, o nana na dayon na siya to resist axial loading, no? Saka na siya. So, importante mga guys, charot mag-vlog na sila. Importante nga makabalo kag reaction. Kay pag abot dito sa higher, na di mo kabalo ko ag reaction, pilay reaction along x, dili mo kabalo, pila inyong force kagamiton nga ilabay ninyo sa formula of stress. So you have to be very practice na ninyo na sa daan dinhi. Kung pwede pa lang kinaon na ninyo ang reaction pagkuha kay pag abot dito sa higher, di na mo maglisod. Ha? So kana since it is bolted or restricted ang movement along x, there is ang kanisya hinge and bearing, this bearing here, no, will not allow this kanisang atong rod or kaning ato ang bolt na move siya along x, y, and z. For radial load, so radial meaning no rotation. So pila po daw kuno dayon, unsa iyahang resisting moment of this bolt given nga mura na siya iyahang unsa dayon kabaga ang kaniong kanato ang atong bracket nga atong ibutang din ha to resist this given nga moment depending on the loading na dayon sa unsa atong ilabay sa tuang body. Pila na din ang maximum. So ingon ana ang design and structure kay aron makabaluta kung pulido ba ang atong structure. So kung dili ta kabalo mag-reaction, magkuag-reaction, di ta kabalo design og mga connections. Kay I tell you, kanang mga pinalit nato nga mga gamit no or mga joints or kanang mga miscellaneous nga mga materials in our in any structure, kinumpit na siya. No? So, sa karon siguro maghunaon ata kada makita ta og mga kuan pila ka reaction ani no magtan-aw lang tong pultahan pila kay reaction ani ako ang pagtulod ani akong pultahan ko ingon ani na siya. So ingon ana na siya kinumpyut gihapon na siya depende kung unsa ka bugat ang imong pultahan pila ka hinges ang imong ibatang dinha unsa ka baga ug unsa ang quality. So ingon ana na siya. No dili lang kay magsalig lang ta sa advertisement sa isa ka material nga kani siya kay quality ni siya and standard. Dili na siya. Ato na siya gina-compute. Kung engineer ta, ato na gina-compute. Okay? So, na siya. Ha? So, since kani, ang ato ang support is not allowed, no? Ang along rotation, pwede siya rotate along the x-axis, but it cannot move along the x and also along the y and z axis, dili sa siya pwede mo rotate diha, di ba? Mo rotate diri. Ang kani po ang ato ang mga hinges, no, makita nato sa atong mga pultahan, sa atong mga cabinets, allowed siya mo rotate along the x-axis, but it cannot rotate along the z and the y axis na. Okay? So, that depends on the orientation kung asa na ay restriction along the restriction on the rotation sa tuang supports and connections. So, kung there is a restriction of movement and rotation, there is a reaction force and a reaction moment or a reaction couple. No? Mo na siyang okay. To apply these theorems that we have discussed, let's try to solve some example problem. Now, we have here a 5 by 8 feet sign of uniform density weighs 405 pounds and is supported by a ball and socket joint at A and by two cables EC and BD. Determine the tension in each cable and the reaction at A. Okay? Now, ang atong body of consideration is this signboard with three forces that is being applied to that to this body. Matulo lang ba? I think dili ay. The tensions EC and BD, its weight and the reaction at A, no? So in your free body diagram at A, when you say ball and socket, unsa gani atong reaction ani? Only three forces, no? Meaning it can rotate along X, Y, and Z axis, but no movement along X, Y, and Z. Okay? No displacement. Now, for our free body diagram, ang atong tanan forces kinahanglan nato o in terms of its vector, no? Or unit vector form kay aron kuhaan nato siya og iyahang x, y, and z components for each of these unknowns, no? Sige. Ato sa i-identify ang atong mga reaction forces. Now, disconnect all forces that is not being applied directly on the body. Okay? So for our tension EC, okay, which is applied at E. Okay? Importante kaya ron makabalot ta sa ato ang position vector. Sunod, for our tension BD. Okay? Mapod na siya. Next is for our AX, AY, and AZ. Wala tay reaction couple or reaction moment at that point kay ball and socket man ang atong gamiton. So pila ka ba pang atong unknowns? 1, 2, 3, 4, and 5 only. Diba? So, what else? Ang naka-apply ani atong body, it is its weight. Asa always located ang weight at the center of gravity of the body. Okay? Now, neglecting its thickness, since it is not indicated, we neglect its thickness. Only it's along its x and y axis, no? So it is located halfway from this point, no? Sa whole body gid ang atong i-indicate. So this is 3 meters from A along x and 2.5 meters from this axis paubos. So that is the location of our weight. Now, for our forces, we express it into its vector form. Before that, we need its diagonal distance ato ang EC and BD, no? In terms para makuha na to ang iyahang x, y, and z components. So ito, you're going to draw a route from the point of application to the next point along its direction. So the directed distance from E to C is equal to botag ruta. Along x, negative. BD pa man guys. So for BD, from B to D, okay, that is negative 8. Sunod, saka ta, positive 4 for our y, and then backward sa itong z, negative 8 yapon. So the directed distance from B to T is 12 feet. For E to C, that is negative 6, saka o 3, positive 3, then forward 3 feet. So the directed distance from E to C is 7 feet. Okay? And then, recall that in our vector form, the magnitude over the distance from this point to that point times xi plus yj plus zk. Okay? We have our values for x, y, and z. Simplify din na itong force vector form. So we have here, okay, negative 2/3 TBDI plus 1/3 TBDJ minus 2/3 TBDK. This is our x, y, and z components in terms of our magnitude sa ito ang tension ED. Next, for our tension EC, we have here magnitude over the diagonal distance times x, y, and z. No? Simplify na to, we have negative 6/70 ECI plus 3/70 ECJ plus 2/70 ECK. Next, we have our force vector for our reaction at A. So since these are the components of the reaction at A, no? So ang ato ang force vector for our reaction at A would be AXI, AYJ plus AZK. Ano na components naman, diba? Next, and lastly, ang ato ang weight. Do not forget our weight and our forces. Kaya appeal mo na siya nag-apply no, on the, directly on the body. That is directed downwards, negative 405 J. Okay? So we now have our forces. Next is we're going to get our reaction AX, AY, and AZ. So the three conditions of equilibrium is summing up forces along X, Y, and Z is equal to 0. So naman tayo X components, no? Y components, and Z components at sa ng isang. Okay, so we have here our first equation that is tipok tanan na to mga X components of our forces and then equate to 0. For Y, no, kanita na na J, tipok po natin sum up and then equal to 0. And then Z component, sum up and then equate to 0. Now, let's count how many unknowns there are there. 1, 2, 3, 4, and 5. So we have 3 equations but we have still 5 unknowns. So dili pa ta maka diretso og solve, no? Kaya mas kung saan nato nag-simplify tungod kay 5 man kabukang unknowns, dili pa gid na siya ma-solve. Okay? So napaman tayo remaining 3 conditions of equilibrium, no? Summing up moments about x, y, and z. So continue ta. Recall that moment is equal to position vector cross force vector. So kinahanglan nato ang ato ang position vector. Now, unsa ito strategy to get the least number of unknowns kung mangita ta og point of moment dito ta sa point nga daghan ang unknowns kay aron ma-eliminate na ning tulo ka buok nga unknowns, no? AX, AZ, AX, AY, and AZ. Okay? Ma-zero naman na siya. Okay? So, kung mag-moment at A, 1, 2 na lang ang atong unknowns. Diba? Kung at B, managhan ang atong unknowns gihapon. So, dili ta makakuha. No? So, dili ta sa A, mag-moment. Conveniently. Now, position vector, recall, as a ganitong position vector, referred from the point of moment padulong sa atoang point of application. Okay? Kaganina ha, ang atong D is from the point of application towards the second point along the direction of our cable. Diba? Or our diagonal force. Karon, ang ato ang position vector is always from the point of moment towards the point of application. So from point of moment at A, padulong sa B, sa manang direction niya, positive 8 along x-axis only. Diba? Kaya abot naman din ito. Gikan sa 8 padulong 8 ay rato ang position vector niya. Next, from A to E. No? Our position vector from A to E is A to E. 6 ay rapod. Diba? And then lastly, ang ato ang weight. Diba? Ang atong weight, gikan diri padulong din ha, this is 8, halfway, 4 ra. Diba? So, gikan diri padulong din ha, 4i. There'll be ang y, ma'am. Okay? So, it could be, no, ato lang i-explain later on kung nganong wala na ilabot si y unit vector niya later. But pwede ra po do in your position vector, you can write down 4i minus 2.5j. Okay? Sige. 4i plus 2.5 j. Minus 2.5j. Wala lang na to na na-appeal dun. Now, ganong ma-zero ra gyapon na siya later. So, recall that the moment at a point of reference, is equal to the summation of all these forces, no, times its position vector. For its position vector of all the applied forces, multiplied by the magnitude of our force. So, we now have for our first, no, sa atong tension BD, position vector times force vector. Okay? Sunod, ang atoang tension EC, position vector times force vector. For our weight, position vector times the force vector. Napabaylain? Wala na. No? Kaya na zero naman. Equate dayo na to sa zero. Okay? So, after equating it to zero, simplify na to. No? So, recall, pwede ra pod nga katong ijk nga i-arrange na to siya, no? O into ijk and then rotate clockwise is rotating clockwise kay negative, rotating counterclockwise is positive. Or you can arrange the ijk vector into this arrangement, no? ijk, ij. So if going to the right kay positive, going to the left kay negative. Okay? So pwede ra sa dingon akong kapuyon mo tong ijk nga ano nga direction na ipag-uyok. Pero same ra gihapon na siya. Now, so I times I. Sa ganito, may mong 0. I times J. Ij to the right, positive K. Diba? So 8 times 1/3, that is 8 over 3 TBD K. Okay? I times J equals K. Sunod, I times K. IK to the left, negative J. Okay? Now, negative naman daan ang atong magnitude. So, negative times negative, may mag-positive. 8 times 2/3, positive 18K, TBD, J. Okay? Sunod. Oh, naman naman tani no sa tuang position and force vector sa tuang BD. Next for our EC. I times I, 0. I times J, kay IJ, positive K. Positive, 18 over 7, TEC, K. Sunod, I times K, IK, negative J. Okay, so negative 12 over 7, TEC, J. Sunod, 4I times I times J. IJ positive K but negative man na siya. So negative 1620 K. 1,620 K. Now, if atong i-add ang atong 4I minus 2.5J, J times J is equal to, so kahit na, may mong 0 ra gihapon. That is why wala na natin i-include. No, so makita mo po na to, no, ang atong force that is parallel uh, to the axis o ang ato apong weight is parallel sa atong axis sa atong y o iyang direction po. So ma-zero ra gyapon. That is why wala na to i-include si J sa to ang position vector for our weight. Okay, kay ma-zero ra man gyapon siya. Okay, now we have simplified our moment at A. Now, ato din i-combine, no? Naman tayo K, K, and K, J, and J. Wala tayo I. So therefore, our moment at A has a zero moment about the x-axis. Okay? So, summing up moment along y, no? Kung saan na ay mga J vectors din ha, combine na to, equate to 0. And then, summing up moment about z, 1, 2, and 3. We have here all of our z components sa tuang moment. And then, equate to 0. Now, from these two equations, we have pila ka book unknowns? 1, 2. 1, 2. So, this introduces two equations with two unknowns na problem. So, pwede din nato ni siya kwaon, no? Ang ato ang tension BD and tension EC. Either i-substitute na to, eliminate, or by Caltech, kuha na to sa tension BD is equal to 151.875 pounds and tension EC is equal to 472.5 pounds. Diba? So, two equations with two unknowns. By summing up moments. So, kung nanatay tension BD ug tension EC, recall that from equations 1, 2, and 3, di ba? Oh, kung natay tension BD, tension AC, kakuha tag AX. Natay tension BD, tension AC, kakuha tag AY. Natay tension BD, tension AC, natay AZ. Okay? So, ato nang i-substitute dito, kakuha tag AX, AY, and AZ nga magnitudes. So, negative ang atong AZ. Unsa gani pasabot? Ana, kung negative, kanang atong direction na towards positive direction, balihon. Padulong dito. Okay? So, dili gid siya ingon anak ka. Sorry. Oh no, I lost my connection.
Kung katong uban dito ang ilaw,
Wala internet? Why? Okay, nawala akong internet class. Okay, dali lang ha. Pangutana, nakuha lang ni siya. Thumbs up tabi sa mga nakasunod ani nga solution nato. Okay, very good. Balik-balik ra gid gihapon ma'am no. Oo, ang ato ang topic sa atong chapter 2, equilibrium of particles ug ang atong chapter 3 gi-combine equilibrium of the rigid body na dayon. Diba? Okay, so sige, sayon pa ni siya nga problem. Next, let's move on to another problem. Itaas pa tong time. Masolve pa ta ani tanan. Now, we have here a rigid L-shaped member ABC which is supported by a ball and socket joint at A. Okay, ball and socket gihapon. Kung ball and socket, pila ka book unknowns? Tulo, X, Y, and Z na forces, and it is allowed to rotate along X, Y, and Z. And by three cables, namely our CD, BD, and DE. If a 450-pound load is applied at F, determine the tension in each of these cables. Okay. Ang tension ra ang gipangita sa cable. But since ang atong free body nga i-consider has a reaction at A, we cannot solve for the tension without determining also the reaction at A. Kaya ato mag-isam up tanan forces nga nag-apply on the body. Okay? So you have to include that in your analysis. Now, for our free body diagram, it is a ball and socket connection at A. So, pila ka ba katong ano? AX, AY, and AZ. Directed towards the positive direction, kaya ron ko negative, balihon. Okay? Now, ang ato ang tension at CD, okay, atong putlon ang mga way labot. Dinha. Di ba? Our BD and our BE. Okay? So, pila ka buka itong ano? 1, 2, 3, 4, 5, 6 na kabuo. Okay? So, let's solve first for the diagonal or the directed distance from C to D. Kaya ron makuha nato ni siya ng mga distances. Kaya ron ang atong forces will be in terms of its or can be expressed to its vector form. So, for tension CD, let's create a route. Ikan sa C to D. Okay. Along Z, that is balik man, so negative 32. Saka ta, along Y, 24 inches. Niabot naman ta, wala man ta niagi sa tong X. So, 0 ato ang X. Okay? So, the directed distance from C to D is 40 inches. For our BD, B to D. Okay? So, along X-axis, negative 42. Okay? Saka dito sa tong Y, 24 inches, positive. Atras dito sa tong Z, negative 32. Okay? So from B to D, that is 58 inches ang diagonal distance. B to E, okay? Along X, ilan na? 42. Negative, positive direct. B to E. Positive 42, negative 32. Ang tod, wala na. Zero din atong Y. Kiniabot naman data. Okay? So, aton, distance from B to E is 52.8 inches. Next, we have RT. Our forces involved in our body are 1, 2, 3, 4, 5. Okay? 5 kabuok. Do not forget the applied or the weight. Applied forces and the weight. Okay? Muna kasagara malimtan include in our forces. Di na din makuha ang answer. No? So, tension CD. Okay? Y and Z lang. So, simplify, we have 0.60 CDJ minus 0.80 CDK. For your tension BD, okay, simplify, we have this expression, our X component, Y component, Z component. Tension BE, okay, wala man tayo Y, so I ug K lang. So, natay X and Z components only. In terms of our magnitudes, TCD, TBD, and TBE. Next, for our reaction at A, we have components naman na siya sa reaction directed towards the positive, AXI plus AYJ plus AZK. And do not forget our applied force na 450 pounds directed downward. So negative 450 J. Okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 kabuk atong forces, 5 pud kabuk ang ato ang position vector. So, but before we get our position vectors, sum up sa nato to ang x, y, and z components. Okay? Ito i-combine tanan x components and then equate to 0. And then for y, combine sa nato and then equate to 0. For our z, combine all and then equate to 0. Pila kabuk nga itong unknowns? 1, 2, 3. 4. Okay, na-count naman si tension BD. 5. Count na po na. Count na po. Count na po. 6 tanan. 1, 2, 3, 4, 5, 6. Oh, kanina 6 ang tension CD. So 6 kabuok. Tulog pa kabuok atong equations. Cannot be solved pa. But, since nag-sum up pa man tag forces, we move on by summing up moments. So, summing up moment about asa man ta mag-moment. Kung asa na ay daghan unknowns. So, dinhita mag-moment at A. Okay? So, kung di na ta mag-moment at A, we solve for, we first get the position vector of each of the forces from A. So, ang AXA, to reaction at A, 0 naman na siya. So, atong kuha na lang ang position vector would be our BE, BD, this applied force and tension CD. Okay? So, for the tension CD, okay, from A to C. Okay, create a route from the point of moment towards the point of application. Okay, so gikan din along X, negative 42. Padulong din ha, positive 32. 0 ato ang Y. Okay? Next, for our tension BD, from A to B. Oh, purely along Z raman na siya. So, 32Z. 32K. Okay, along the Z axis. Next, for your tension BE, from A to B. BE lang po. So, 32K. Okay? And then, for our 450 pound, okay, of our force, that is from point A, positive 32, negative 21. Okay? Do not forget, kung ahana sa parallel na axis ha, pero dito ninyo nabutang I or A. Sunod, natay position vector, natay force vector. So we can now solve for the moment at A by summing up the position vector cross the force vector. Okay, so position vector for our CD, una, times force vector. Sunod, ato ang BD. Okay, position times force vector. BE na po, position times force vector. Sunod, our applied force. Position cross force vector. Napabaylain? Wala na. So equate it to 0. Okay? So after equating to 0, pwedeng tag-sa multiply, distribute nato na siya. Okay? So pwede lang nga kani inyong gamiton, pwede pod katong naka-arrange og I, J, K, then counterclockwise ang positive, clockwise ang negative. Pwede ra pod kung ani nga position, to the right positive, to the left negative. Okay? So, ang kani nga method kay this was introduced by one of our instructor no si Engineer Mary. So mo pwede ham convenient nga gamiton. So if you are convenient pod ngayon ani, walay problema. Sulat lang mo din sa inyong papel IJK IJ para dili mo malibo. No, sa inyong sign convention dahil sa inyong final answers for your solution also. So, sugod. So, I times J, IJ positive K. So, that is 25.2 TCD-K. No, negative kay negative man ato magnitude daan. Next, I times K. I, K, negative J. To the left man. Negative naman na daan, making it negative, negative di ay. So, negative di gihapon. No? Kay negative na daan na magnitude, multiply na to og negative nga unit vector. So, may mo gihapon siya negative. Okay? Tulo ka negative tanan. Making it negative. I times K, J. Sunod. K times J. K, J, negative I. Okay? So, 19.2 TCD I. Okay? Sunod, K times K, 0 na. No? So, manataan nga sa tuang CD. Next, sa tuang BD. K times I. Ki positive J. So, negative ba na, making it negative 672 over 29 TBD-J. Okay? Sunod, K times J. KJ, negative I. Okay? Both are positive ang magnitude. So, negative 384 over 29 TBD-I. Okay? Sunod, K times K, 0. Wala na. Sunod, proceed. K times I. Ki positive J. Positive man. So, positive, 32 times ka na siya, no? Ato ang force, ato ang x component in terms of our magnitude, that is 25.4528 TBE-J. K times K, 0 na. So, wala lagot po. Sunod, I times J. IJ positive K. Both are negative, making it positive, may positive man. So, we have 9450K. Okay? Sunod, K times J. KJ, negative I. Positive, negative, negative, negative. May mong positive, 14,400 I. Okay, so, distribute na dato tanan og multiply, and then, equate to 0. Okay? Combine din nato tanan I, J, o K. So that we can sum up moment about A. No? Simplify na to. We have summing up force moment along X is equal to, naman akong X. Tanan na I. Negative 19.2 TCD minus 384 over 29 TBD plus 14,400 I. So, equate to 0. Okay? Butangan lang nato nag-space din ha. Kaya atong itungod ang ato ang tension BE. Kaya aron, ay mo siyang 3 equations with 3 unknowns later on. Now, summing up moment about Y, we have negative 33.6 TCD minus 672 over 29 TBD plus 25.4528 TBE. And then equate to 0. Sunod, summing up moment about Z, we have negative 25.2 TCDK and 94 plus 9450K, and then equate to 0. Okay? So we now have 3 equations with 3 unknowns to solve for our tension CD, tension BD, and tension BE. Diba? Kung 3 equations with 3 unknowns, naman tayo Caltech to check our solution, mag-substitution ta, mag-elimination, however you solve your unknowns is accepted. And in our midterm exam plaza, I will allow the Caltech given that correct ato ang equations na gani sayop miskin sign na would be equal to demerit points. Ha? So minus na siya. So kana tension CD, tension BD, and tension BE. Okay? So kung na natin tension CD, BD, or BE, okay? From equations 1, 2, and 3, if we have our tension BD and BE, we can solve for our AX. Tension CD, BD, we can solve for our AY. Tension CD, BD, and BE, we can solve for our AZ. No? So with that, AX, AY, and AZ is equal to these values. Although, from the problem, hindi pangita is tensions only, di ba? So, di na po tama ang atong i-box kay wala ra ba pangita from the problem. Okay? Unless, otherwise, it was required na pangitaan ng reaction at A, then, dire, tama ang atong solution. Okay? Thumbs up if nakakuha. Okay. Questions? Yes, Miss Saliot?
Sa pribadi ibalik ko ma'am.
Ano sa to?
Sa pribadi ma'am ba ibalik kay na ako'y question. Ang dira ba ma'am ang pag-determine sa unknown maskin ang support kay yang naka-connect siya which is ang connection niya kay cable ang pag-determine sa unknown kay sa connection mag-base dili sa support nga nakasakit.
Okay. Ang at A, muna siya i-out. This body, kaning ato ang A, B, C nga L-shaped rod is being supported by this point at A with the ball and socket point at A, the cables at C, no, CD, BD, and BE. So, ideally, kung magkuha ka og unknowns, no, i-check na to dito sa ato ang table. Okay? Dito sa atong table nga gi-present kagani no, ball and socket. Wait lang. Oh, dire. So, ball and socket man, automatically at A, you show your three unknowns. Okay? So, no, at the cables, naman po tayo cable. So, obviously, we'll write down kung unsay ato ang unknowns at these cables. So, given man ang ato ang line of action through the diagonal distance no, from the point of application towards the second point kung asa nato gikawit ang atong cable, mo na po na siya yung direction. So, isa na po kabuk ang iyahang unknown ana niya. Okay? So, kung mangita ka, mag-identify ka og unknowns, first nimo gyud buhaton is sa imong free body diagram, identify asa dapit gisuportahan. Ay number 1 is identify what body are you going to consider. Diba? Sa itong free body diagram, katong step by step, identify what is the body of consideration. And this, detach all other forces that is not being directly applied to the body. And how are you going to identify all the forces being applied to the body? Number 1, pangitaon, is ang iyahang applied forces or its own weight. If it is not indicated nga apilon o consider ang own weight, then dili na siya nato i-apply sa free body diagram. Next is pangitaon na to kung asa siya supported. No? Kay supports when the body is being supported, na siya iyahang own reaction din ha. And the different types of reaction for different types of supports and connection, lahi-lahi sila, di ba? As mentioned in our table. So at A, it is a ball and socket. So apilo na to siya sa tuang consideration sa tuang body. Kay kung dili na to na i-include sa tuang analysis ang atong reaction at A, this body is not in equilibrium. Kaya nga naman, Imagine a body being supported only at these cables, dili gid na siya stable, no? Unless ato na siyang ibutang in a ball and socket din ha, no? Dili na siya mulihok. Okay? And then since mo na siya ato ang body of consideration, considering all the unknowns, kay cable man na, so na gila siya force. Always known ang iyang direction. Magnitude ra ang wala. Ang reaction at A, no, since it is a ball and socket connection, it is restricted to displace at any axis, but it can be rotated along X, Y, and Z. So, ang atong reaction din ha would be along the forces along X, Y, and Z only. Okay? So, ang imong pasabot sa imong pangutana is maora ba gid siya ang ato ang forces nga i-consider. So, first gid na to nga i-consider sa tong analysis is to identify unsa ang type of supports. Dayon, i-refer na to dito sa table, atong i-check kung unsa na siya pila ka buk ang reaction sa ingon ani nga support. So, forces raman for a ball and socket. So, mo po na siya to ang unknowns din ha, nga point. Sunod, ang atong mga cables, kay supports magyapon siya. Pila din kabuk ang atong unknown at that point which is connected to this cable. So, mo na po dayon na siya. Okay?
Follow up ma'am kanang example
Yes.
ma'am reaction at A and B. So ang iyang body ana
Mm.
isa ra gyapon ma'am. Maskin reaction at A and B ana
Okay.
or duha.
Your reaction at A is only AX, AY, and AZ. Okay? At A lang gid nga point. At B, moingon ka og reaction at B, duha ka buok ang atong forces na included ana. That is BE and BD. Duha pud ka buok sa iyaha din ha. Ay duha man ka buok ang nakakonect. Okay? Ang atong body, number one, is kani gyud, no? This is a homogeneous body, ang ato ang ABCL shape. So kana siya atong i-consider. Kana gyud siya tibuok.
Last na
Okay?
lang ma'am.
Sige daw.
Kanang if kuan ma'am reaction A and B pero ang iyang total nga unknown ana dili gid gyapon molapas og 6 maskin duha ang reaction.
Bali putlo ni mo ning body din ha rataman wala ni labot. At C.
Ay kanang sa mga example ma'am ba, like sa mga mabasa nga example nga reaction duha nga reaction A and B tapos kanang
Okay.
nya naka 3D man siya so dili gid gyapon molapas og 6 unknowns maskin duha ang reaction nga gigiven.
Yes. Dili na siya mulapas gyud og 6 ka buok. Kay either naay mag-given ang moment ana kay aron ma-solve mo ang other unknowns or kuan. Ingon ana no kung imo pasabot is ball and socket could be select reaction at B. Ana lugar na wala ning tension cables BD and BE. So at P, if it is in a ball and socket, then at P atong i-analyze siya nga tulog yapon kabukyahang unknown. If ang iyang kuan ana would be a roller, no, with one restriction only of the force, then nay duha ka forces ana pod niya. Depende ra gid na siya gihapon sa iyang connection gang. No kay again, pag free body diagram na to, kung pila, kung unsa iyang type of support, atong i-draw sa to free body diagram kung pila ang iyang reaction, forces, or reaction couple niya. Dili po pwede nga, dili na to i-include kung unsa kay. For example, for this example, duha ra man ka buok tension cables ang naka-attach niya. So, duha ra pod ka reaction force niya ani. Okay, in terms of its detentions niya. Pero kung ball and socket na siya, si B, tulog yapon kabukyahang ana. So probably kung ball and socket na siya, with our problem, mawala na sana si tension CD. Kay managan man pud ang ato ang unknowns, di ba? So
Gets
depende
ko.
lagi hapon na siya.
Thank you ma'am.
Okay. How about the others? Any questions? Sa pagkuha na to sa reaction ha, different types of reaction. Balik ta dito sa table. Tanaw na to kung unsa ang iyahang type of support, then balik ta dito sa table, i-project dito sa to free body diagram, and then ano din to? Sum up moments, sum up forces, then you can solve for the unknowns. Limited to 6 unknowns only. Yes, Mr. Doria.
Ay, ma'am, good morning, ma'am. Kanang sa instances bito, ma'am, na for example, like special case bito na support, ma'am. Kanang in determining reactions, ma'am, sakto ba ang paghunahan na, ma'am, na kung asa siya dili maglihok, dira ang reaction, ma'am. Like imagine nimo asa siya dili maglihok ang
Yes.
support.
Kay, for example, ato no, dito ra gihapon sa table nato. Kung asa na ay restriction of movement, okay? The body will act, no, or exert a force towards the body of our consideration. Okay? So mo gid ato ikon third law of motion. In every action, kung si body na siya action towards the surface, si surface nasa da siya iyahang exert towards the body. Okay? And that depends on how it is being supported or connected from the surface or from the other body towards the body of consideration nato. Okay? Ano na siya ang trick, anak. Kung gusto ka makabalo kung unsay direction sa tuang or unsa nga mga reaction forces ang present to the body, always look for the axis kung asa siya restricted to move such that ang katong restricted or kaning like for example for this example na ato roller gipatong man siya din ha, it is restricted to move along the y axis freely, no? But tungod kay ang kanipong roller na to muligid man siya freely to move along the x-axis, there is no reaction force, no? Since na pin connected man siya din ha, dili sad siya pwede mo lihok along the z-axis, no? Unless a force is being applied that could move, no? Since rigid man atong body, there is a certain force na atong pwede siya ma-move towards the z-axis. But since naman siya ang kaning pin niya, no? Kusgan man sad na siya, there is a reaction force from this point that will exert to the body. Either na dayon kung unsay mas kusgan ang bolt ba or ang body, then din ang maguba, no? So pag-abot na din na siya dadto sa ato ang strength of materials nga topic kung asa ang maguba, either ang support ba, no, ang pin connection ba or ang body. Kay ang atong pangitaan karon is ang reaction lang man sa, no? The force being exerted by the bolt towards the body along the z-axis. Kaya ang kanima pong bolt ang ga-restrict of move ani along the z-axis. Okay? So, what else? So, fixed support. Restricted ba na siya gyud move along x, y, and z. So, along x, y, and z, wala po siya rotation ni ana. No? For these special types of connections, you have to inspect first kung sa iyang orientation kaya aron makabalot ta kung sa siya nga axis restricted for rotation and movement for the x, y, and z. Okay?
Okay, ma'am. Thank you, ma'am.
It's already 10:30 but napadin tatay isa ka problem. Sige. This will be your assignment na lang. Okay? So we have here an assembly shown is welded to a collar at A that fits on the vertical pin shown. The pin can exert couples about X and Z axis but does not prevent motion about or along with the y-axis. For the loading shown, determine the tension in each cable and the reaction at A. So I'll give you a hint. Charot, ato rin din. Sige lang. Ato lang ning i-discuss later on, but try to solve it on your own. No, dili gid siya official nga seat work or an assignment, but ato lang gyud pwede siyang i-discuss next meeting nato. Since makamit pa man ta before midterm. And then ato na lang nang i-dedicate ang atong next meeting sa ato ang ay hala nanday ko yung workshop anong 6. Sige. Yes, Mr. Aguilar.
Yung sa problem lugar ma'am kay kung pag-identify sa movement ma'am kay dili siya bitaw diretso like movement siya in a specified axis bitaw ma'am. Murag naka-segment.
Yes.
Wonder na siya ma'am
Ana
kanang
gyud.
identify pa nimo ang kanang unit vector sa katong segment that product then ka mag R cross F.
Oh. Mag-dot product? Ano mag-dot product pa man?
Kanang sa kanang
I don't-
movement bitaw naa siya'y specified axis bitaw ma'am.
Okay.
Di ba na,
Ah, okay.
like kanang sa problem nga naa siya'y moment nga determine the moment kanang segment AB kani nga na.
At segment AB,
Mm.
what do you mean na segment AB? About an axis, ana lugar?
Oo ma'am ana ma'am.
Ah, okay. If it is about an axis, then pangitaon lang na tuod sa siyang orientation on that axis. Ayun, mga po rin na siya iyang moment. But, just a hint, sometimes in the problem, gina-indicate na siya actually kung asa ang freely rotate, it can freely rotate or it can freely move along a specific axis. Just like this problem, no? This spin at A can exert couples about x and z axis. So kung maka-exert siya og x couples or moment about x and z axis from the figure. Ito pong i-analyze si figure. Si figure, ang kani atong pin, it is not uh, restricted to move along the x-axis kay this is a rod, di ba? Sa may pasabot ani kong rod, it can be rotated along the y-axis. So there will be no reaction moment or reaction couple along the y-axis, only along x and along z-axis. No? Tanang po dato na ko ingon ana ang connection, di ba? The only rotation that it can generate is along the y. Kana dili na siya pwede mo rotate along x o along z. Okay? So na ay hint from the problem oftentimes, no? Na pwede na to ma-identify kung asa ang unsay reaction at a certain connection in the problem. Such as at A, no? It can freely move along the y-axis and it can also rotate about the y-axis. So the reaction moment from this connection would be along x and along z only. No? Dili man po siya allowed to move. No? Mo displace along x and z axis. So there will be also a reaction force, no? From this rod towards this body nato at A. So for your free body diagram, your reaction forces would be the tension cables CF and DE, and what else? The force reactions AX, AZ, and your MX and MZ. No? Ang rotation, no? The restricted rotation along X and along Z axis. Okay, so inana na to free diagram na yun. AX, AZ, the moment at X, and the moment about Z. So pila ka buka tong unknowns? 1, 2, 3, 4, 5, 6 gyapon kabuo. Okay? So, kuan naman ta no, overtime naman ta. So, continue ta next meeting for this problem. Napay pangutana.
Present day ko ma'am.
Present ka. Yes, Mr. Doria.
Ay, ma'am, wala na
Pataas
tayo.
ka ba sa katong mga late?
Ay, ma'am, wala na tayo assignment, ma'am. Or, okay na ito, ma'am.
Assignment.
Eh, like, seatwork,
Okay.
wala mga mga seatwork.
Sige, maghatag ko sa inyo og assignment number 4. Di ay ninyo to be submitted next kano sa ganina kanang a week before sa to midterm. November 6 to November 10 na nako i-collect. Ay, midterm naman na. So November 8 lang din ako i-collect ang inyong last na assignment. Okay, pataas kamot sa mga late. Okay, mura po na to ang mga magpataas og kamot. Si Aguilar, Paul,
Sige ma'am Kat, kung unsay mas maayo sa imong kuan.
Pamplona.
Oo, sige ma'am, salamat kay ma'am.
And then Udasco, Acebu, and Gulis. Okay, wala po kaapas naman ka kanina. Okay, so that would be all for today, everyone. Thank you for your attendance. Class is dismissed. See you.